Hello everyone, I am Showardopal and today we will be doing result analysis and report generation of pyramidal horn antenna using HFSS. So these are the things that we'll be doing today as part of report generation and result analysis for the pyramidal horn antenna as I said. So let's move to the HFSS section. So this is my model, and you can see this model have been created, and now we will doing the various graphs and reports so we need to have for the analysis of the antenna. So for the first, as you can I have already have a PDF in which I have attached the screenshot as in the form of a report, and I'm going to tell you how you can get your report similarly. So the first part is the antenna configuration and the dimension. So for that, what you need to do is go to HFSS design properties, and as you can see there are many other many variables already present over here with many dimensions, and you need to take the screenshot of this. And one thing that you can do is to get what variable represents what, you can do is go to the shapes and 1 second. Yes, you can go to the shapes, and there as you can see there are the dimensions that are being used, and here are the variables that are being used. So to get the values of the variables, you can go to the HFS design properties and view the various variables that have been used in the model, and you can also change the values according to your need in the model. So we are going to attach the this section in the report, uh, and the variable name should be named in such a way that the actual meaning can be understood of what length it represents or what dimension it represents. So the first part is complete, and you can see in the PDF here are the dimensions that I have attached. You can also attach your dimensions accordingly. So for the second part is the return coefficient, or the reflection coefficient you can say. We need to plot that, and the graph will look similar to this, and I'm going to show you how you can plot yours. So first thing you need to do is go to this, after doing analysis of all the solution, to go to this. The one thing that I need to tell you is that we need to take care of the frequency that we are using. So I'm going to use the 14 gigahertz as a solution frequency, and a frequency sweep of 8 to 40, and you can do and adjust according to your need of the antenna. So for the first result, with the reflection coefficient, what I'm going to do is go to the result section, and the first plot is that, I think. So yes, the first plot is of the dbs11. The S11 represents the reflection coefficient, and can the both mean actually the same thing, and actually plot the dbs, the S11 parameter, and it is also the reflection coefficient. Now one thing, if you don't have this thing in your result section, you can go to this section and create model solution data report and rectangular plot. And what the S parameters, you can see S11 and db is selected. Now you can click on new report, and this graph will be created. This will take some time, and I have already created this. As you can see, this is the nature of the graph, and I have marked all the possible peaks or troughs in the graph, and we will be using these things after later on. We will be needing those. Okay, so the first part have been completed. You can see the next part is resonance frequencies. So for that, what you need to do is, as you can if you see the PDF for the resonance frequency, what you need to do is you need to find all the troughs in the graph, not the peaks or the troughs where there is a big dip in the reflection coefficient. So as you can see, there are the three big dips in M1, M2 and M3, and the M1, M2, M3 in the corresponding marker positions are this one, and these are the frequencies. For plotting the markers, what you can do is go to marker, add marker, and you can plot accordingly. So here are the markers that I've already used and taken the screenshot. You can also take your screenshot and attach it in the PDF. So the frequencies that I got as resonance frequencies are listed in this 13.28, 19.64 gigahertz and 26.1 gigahertz. So for the next task, we need to find the lower and upper cutoff frequencies, and in the for finding that, what you need to do is go to this graph, reflection coefficient graph, and you can see there are two markers, m5 and m4. These values are at like 15, the point -10. This is -20, -15 and -10. Both the values are at -10. And what you need to do is this one is the upper cutoff frequency, this is the lower cutoff frequency. You need to subtract both of them to find the bandwidth in the next case. And this is the upper cutoff frequency and this is the lower cutoff frequency. So up to this part we have cleared the thing, and let's see what's next. So after that, impedance matching is a variation of real and imaginary part of the input port impedance. Okay, so the graph will look similar to this. I will show you how you can also get your graph. So this one is this, I suppose. One second. No, this one is not this one. Okay, this is also not this one. Yes, this is the variation of the Z. Real part and the imaginary part. Here the color key represents which graph represents what, and this is the variation of the real and the imaginary part of the impedance in the input port. And if you don't have this graph, how you can also easily plot this by going to this, I think, rectangular plot, z parameter and z11 and z11, and this. After that, you need to select to real part or imaginary part according to your need. The real part will represent the real part, and after that, if you also want the imaginary part on the same graph, you need to select that and click on add trace, which is not which is now disabled now because I am not going to add that. So I'm going to close that right now because I have the graph. So this part has been completed. So you can see the next part is the variation pattern plotting. Okay, so for that, what you need to do is, as you can see, this will look something like the in 3D form, 3D polar form. As you can see in the 3D polar plot, I have already created that thing. Yes, this is the thing, as you can see. One second. Yes, so this is the thing that you can see. This is the polar representation of the radiation pattern, which is also replaced by the gain total in dB form. So you can also do that by going to this and create far field report in the 3D polar plot, and you can select the gain total in dB format and set the frequencies accordingly from here. If you want different frequency, you can use the sweep and change the frequencies over here differently, and click the new report part after that. As you can see that I have already created the report, that's why I'm not going to create another, and you can create in your case. Just wait for a second. Okay, yes, so this has been corrected. So we can move to the next part. So that is the rectangular form. So we need to plot the gain in the phi in the rectangular form. So for that we can click on this. This is the graph that is shown in this figure. Yes, so this is the actual figure of the gain theta and gain phi at phi 0 degree and 90 degree respectively. You can also plot yours by going to the results section and create far field report. This time use rectangular plot in this case, and gain theta or gain phi accordingly, and dB as a unit if needed. Then you can change the frequencies and the phi for which you need to plot. In this case you can see I have plotted for 14 gigahertz and phi 0 and 90 degree. So you can change the phi from all to respective 0 and 90 degree, and the frequency to be 14 gigahertz or any other frequency. So this thing represents the radiation pattern in a rectangular format. And other than that, now after that what we have left is the electric field and the magnetic field, the distribution over the antenna. Okay, so I'm going to show you how you can do this also. Just go to this model section now, because the graph section is complete. So in this model, as you can see, doing what you can do is just click on the thing that you need to plot. Like this is the surface. Click once again. Yes, so go to the J surface. This is the of J surface. Like, yes, after calculation you can see the graph have been the distribution have been created. And you can also create a distribution by going to horn plot fields J and J magnitude J surface, which is the current surface current will be plotted. So after that you can see you can create yours also using the same method. And this is for that. And if you want to plot the electric field and magnetic field along this axes, you can do so even by going to okay. So you can also go to electric field and the vector 1. The vector 1 is where distribution of electric field along this axis, and the vector 2 is the distribution of electric on this axis. You can do so by going to, if you create also by going to line X on line 1. You can see line X is this one. Okay, look, wait. One second. Yes, you can create the select this line X and can plot fields electric and the vector electric. You can plot this in this manner, and you can visualize the field distribution of the electric and the orientation in the over the line as I have shown you in this video. Okay, and after this you can easily visualize and create your own electric field distribution over the region or over the antenna, over the space according to your need, or and you can attach the screenshot in your lab report. So for the next task we need to view the characteristic impedance. So for viewing the characteristic impedance, what we need to do is go to the result section, solution data. Yes, so this has come. You click on Z0, and this is the Z0 is the characteristic impedance, and you can see this is the resistance part, this is the reactance part, and this shows how much is their characteristic impedance. The only part left is the radiated electric field and magnetic field. I have already shown this part in this just the previous case, and this is the exactly the same graph. And you can also plot different the electric field and magnetic field in different areas other than these sections in your model accordingly. And as you can see that generation of each and every plot takes time. That's why I have already created those graphs and plots, and I've already shown what is the method for creating individual graphs. And this is complete. Okay, so we have actually completed all the tasks that we need to do. And thank you for having with us. I hope you have loved the video.